My lords, my ladies, and the ordinary townfolk, all ye in attendance gather round. As the official town crier for the town of Markham, I have an announcement of great importance. I read, on behalf of the Markham Village BIA and the businesses of Main Street, Markham, I hereby cordially welcome you to the grand opening of the Main Street Markham Farmers Market, featuring the Science Rendezvous.
Too, and that's exactly how, how as adults we pick up things. We use what's called a pincer grasp because it's a very effective way for obtaining objects. Why is picking up Cheerios important, you might ask? Well, the ability for infants to obtain objects is crucial to their cognitive development because the interactivity between objects and intellectual advancement is a crucial link that we study in this lab. So now that's what the way that adults pick up the Cheer. But imagine, so what we're trying to do today is we don't have babies to simulate this for you, so we're going to try to simulate with you. So I'm going to ask you, these are all brand new baby socks, I'm going to ask you to wear this actually, like that. I'm going to ask you to, Dad as well, to wear this sock. Now, so now I'm going to ask you to try to pick up a Cheerio.
That's exactly what he does, too.
A little more challenging, isn't it?
Why?
Yeah, a little more challenging. So now I'll get you to try that as well. Okay. Oh, okay. Well, good, good.
Up to you.
Obviously, Mom is always smarter, of course. Okay. So now what I'm going to do is I'm going to get two adults here, so we're going to have a little competition.
Ooh.
So now we're going to see. Okay.
Can you just hold it recording?
Okay. So 1, 2, 3, go.
Look at the mess they're making.
That's all right. This is a baby lab. We're used to it. As long as you don't vomit.
But drooling is allowed?
But drooling is optimally allowed. Absolutely. 1, 2, 3, and stop. We'll pick them up after. I'm just doing the count here, but I suspect that Mom has obtained more Cheerios than Dad.
I concur.
When the object comes to this, so these two conditions are very interesting because we have full transparency and partial transparency. And under these two conditions, which do you think, if you look at those two, which do you think the infants are going to have more time struggling to get to the object? Which will be more difficult for them to find?
To get to?
Yeah.
Probably the striped one.
Why do you think that?
Because the other one's fully transparent.
Right. So that's a good adult
No,
interpretation.
actually, it's probably the transparent one. They think they could grab it, right?
Exactly.
Like they can go right through the plexiglass.
Exactly.
Yeah.
There's a rich science of the transparency effect. And transparency, I mean, your response is a great response because it's the typical adult response.
Right.
Transparency would mean, I know its location. What infants do in this study is they work as hard as you can imagine to go through this object. They go like this, they go like that, they point to it, you see them, they actually get down and they mouth it. So they do some very dynamic things.
Hello, I'm Stephen Morris from the University of Toronto Physics Department, and I've got a Rubens flame tube to show you. What it is a pipe full of propane with a lot of little flames on it, and then we make a musical note inside the pipe with this explosion-proof speaker. And watch what happens to the flames. I get just the right frequency, I can fit just a certain number of wavelengths of that frequency in the pipe, and wherever the sound is loud, we get a high flame, and where it's quiet in the pipe, we get a low flame, a high one. Let's try for a higher frequency.
So this is another demonstration of waveguiding, the fact that light doesn't always travel in a straight line. We have here another laser with a laser beam that through air travels in a straight line. Then here we have a water bottle with a jet of water coming out of the bottle, and we see that inside the water, the laser beam is following the water jet and it's bending down. So we see the straight line coming from the laser to the bottle, it's going straight through the bottle, but then it will follow the water jet, and you see the water jet is all lit up with the green laser light, going all the way to the tray at the bottom. All right, so here we have the piece of gelatin which is guiding our light wave. When we send in the light, for some angles, light will just go straight through in pretty much a straight line. For some other angles, it will curve and it will bounce around inside many, many times to follow the curvature of the waveguide going from one end to the other. And that's why we call it a waveguide, because it guides light from one end to the other. Our longest waveguides are many, many hundreds of kilometers long, going from one city to another, or even going under the ocean from one continent to another. And this is the principle behind it.